Today, we'll cover an important topic, solving inequalities algebraically. In this lesson, we're going to learn how to handle inequalities in equations with two variables. Let's start by understanding what it means to solve inequalities algebraically in two variables. When we solve linear inequalities like 3x plus 2y greater than or equal to 12, we're looking for all the possible pairs of values for x and y that make the inequality true. In other words, we want to find a set of points on a graph where the inequality is satisfied, rather than just one solution. This makes inequalities different from equations. Instead of a single line, inequalities give us regions on a coordinate plane. Here are the key steps to solve linear inequalities in two variables algebraically. First, we may need to rearrange the inequality to isolate y on one side. This makes it easier to graph the inequality and understand which region satisfies it. For example, if we start with an inequality like this, we can rearrange it to get this. This helps us identify the slope and y-intercept for graphing. Next, we graph the boundary line of the inequality, which comes from the corresponding equation 3x plus 2y equals 12. If the inequality is strict, using less than or greater than, we'll use a dashed line, meaning points on the line itself aren't part of the solution. But if the inequality symbol is less than or equal to or greater than or equal to, we'll use a solid line, since points on the line are part of the solution. After graphing the boundary line, we shade the area where the inequality is true. A simple way to check which side to shade is by testing a point, like the origin, 0, 0, to see if it satisfies the inequality. For example, if we have 3x plus 2y greater than or equal to 12, we'll shade above the line. Following these steps helps us represent the solution to inequalities in two variables as regions on the graph. This will prepare us for working with multiple inequalities in future examples. Let's practice these steps with some problems. Solve the inequality and represent the solution on a coordinate plane. First, let's rearrange the inequality to isolate y. This will make it easier to graph. We'll start with the inequality. Subtract 3x from both sides. Divide each term by 2. Now we have the inequality in slope-intercept form, which we can use to graph the boundary line and determine the solution region. Now, we'll graph the boundary line, which is given by the equation y equals minus 3/2 x plus 6. Since our inequality symbol is less than or equal to, we'll use a solid line to indicate that points on the line itself are included in the solution. We can see that the y-intercept is at 0, 6, so we'll place a point there. The slope is negative 3/2, meaning for every 2 units we move right, we go down 3 units. Starting at 0, 6, we move 2 units to the right and 3 units down, landing at 2, 3. Plot this point as well. With these 2 points, we can draw a solid line representing the boundary of our inequality. Now that we have our boundary line, let's determine which side to shade. Since this is the inequality, we'll shade below the line to include all points where y is less than or equal to negative 3/2 x plus 6. To verify, let's use a test point. The origin, 0, 0, is usually a convenient choice. This is true, so we'll shade the region that includes the origin, which is below the line. This shaded area represents all possible solutions for the inequality. Which of the following represents the solution set for the inequality 2x minus 3y less than 6 on a coordinate plane? To solve, let's start by rewriting the inequality in slope-intercept form, which will allow us to identify the correct line and shading direction. Subtract negative 2x from both sides. Divide each term by negative 3, remembering to flip the inequality sign. This tells us that the inequality represents the region above the line y equals 2/3x minus 2. We'll need to graph this boundary line next. Let's graph the boundary line given by y equals 2/3x minus 2. Since the inequality is strict, greater than, we'll use a dashed line, indicating points on the line are not included in the solution. Then, we'll shade the region above the line to represent y equals 2/3x minus 2. The y-intercept is at 0, minus 2, so we'll place a point there. The slope 2/3 means that for every 3 units we move to the right, we go up 2 units. Starting from 0, minus 2, we move 3 units to the right and 2 units up to 3, 0, and plot this point. With these points, we can draw a dashed line through them, representing the boundary line. Since y greater than 2 over 3x minus 2, we'll shade above the line. So, option A is the correct answer. Great work today! Let's recap what we've learned about solving inequalities algebraically in two variables. Understanding solution regions for inequalities. When we solve an inequality in two variables, the solution is not just a single line, it's an entire region on the coordinate plane. We represent this region by shading it, and the line itself acts as the boundary. Using slope-intercept form for graphing. To graph inequalities, we often rewrite them in slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. This makes it easy to draw the boundary line and understand the direction of the inequality. Identifying solid versus dashed lines. Use a dashed line for less than or greater than inequalities, meaning points on the line are not included in the solution. Use a solid line for greater than or equal to or less than or equal to inequalities, because points on the line are part of the solution. Shading the solution region. We shade above or below the boundary line based on the inequality sign. A simple way to check is by using a test point, like the origin, 0, 0, to see if it satisfies the inequality. With these steps and strategies, you're well prepared to tackle any problem involving inequalities in two variables. Keep practicing to make these steps second nature. See you next time.